Okay, so in part A here, we're asked to draw 3f of x. Now remember, when the number transformation is outside the bracket, okay, it affects the y values. And in this case here, it's 3f of x, so 3 times f of x. So we've got to times the y values by 3. Okay, now look at the y values here. And our y value there is 0. So if I times that by 3, it's still going to be 0. Okay, so in effect, that doesn't move, right? So we're still going to have minus 5, 0 there. Okay, the x value, well, nothing happens to the x values anyway. Okay, it's just the y values that change. And timesing it by 3, still be 0. Same here, 7, 0. That stays a 7, 0. It's this value here that's going to change, yeah, the minimum. So it's going to go, times that by 3, it'll become minus 6, won't it? If we times it by 3, triple it. Okay, it'll stay as a minus, but it becomes minus 6. So it stretches. The x value will stay the same, won't it? So we'll have down here somewhere, okay, 1 minus 6. Okay, so you can draw your quadratic, okay, I say quadratic f of x. Okay, obviously it looks like a quadratic curve here, doesn't it? Smiley face. And we've got our new minimum point. Okay, so for part B then, we're asked to draw f of minus x. Okay, so this time, of course, the transformation is inside the bracket, so we're going to affect the x values, yeah? Okay, and there's a minus of the x. Now you might be thinking, oh, well, what do I do here? What do I do to the x values? Well, think about it this way. We're timesing x here by minus 1, aren't we? Okay, that's what's going on. We're timesing the x values by minus 1. But of course, in the bracket, you've always got to do the opposite. Okay, so instead of timesing by minus 1, we should be dividing by minus 1, if that makes sense. Okay, because we always do the opposite. Now, dividing by minus 1 has the same effect as timesing by minus 1. Okay, so basically, it doesn't matter how you think about this. You could divide the x values by minus 1 or times the x values by minus 1. It'll be the same thing. So if I times that x value there by minus 1, it'll become minus 7. Okay, so we have minus 7 here. Alright, if I times this x value by minus 1, okay, it'll minus 5 times minus 1 will be plus 5. And if I times this x value by minus 1, I'll get minus 1 minus 2. And notice the y values stay the same because we're just affecting the x values. So we get something like that, okay? Now, if you note to put the two side by side, my sketch obviously isn't perfect, but what I want you to notice there, that f of minus x, right, with it minus in the bracket there, is simply a reflection in the y-axis, okay? So everything gets reflected in the y-axis there, okay? So that point there has gone here, this point here has gone there, and then the minimum has gone on the other side. So f of minus x is a reflection in the y-axis.